Good evening, everyone. Myself Gautam Sarma. I welcome you all in behalf of Sapience Education. So today I am going to discuss about the chapter thermal properties of the matter, where I am going to discuss about anomalous expansion of water and thermal stress in a rod. Right? What is anomalous expansion? Anomalous is that is peculiar behavior that is totally different from other most of the matter, right? So water has a special property, and that property is known as anomalous expansion of water. So let us discuss. See here, what actually happens here. You can understand from graph that there is a temperature T. As soon as temperature of water will increase, so what will happen? See, from 0 to 4 degrees Celsius, as soon as temperature will increase, for general matter, what happened? Temperature is directly proportional to volume. So as soon as temperature will increase, so volume will increase. But in water, what you see, as soon as temperature is increasing, volume is decreasing. But in water, T is inversely proportional to volume up 0 to 4 degrees Celsius. Okay? At the same time, at the same side, generally what happen when temperature increase, so density will decrease. That is, temperature is inversely proportional to density for general. Okay? But as soon as you talk about water, so this is for water, right? This is for water. This is for general property. This is your general properties. Okay? This is your general properties, right? General properties. And as we talk about water, so from graph you can imagine that temperature is directly proportional to the density. So if temperature increases, density increases from 0 to 4 degrees Celsius. So this is the peculiar behavior of water. See here, see see, from 0 it has water has density at a 0.995 and 99985. So as soon as your temperature start increasing, so density should decrease, but in spite of decreasing, its density start increasing. Got it? And this is up to 4 degrees Celsius only, and this is for water only, not for every material. Every material what behave is that as soon as temperature is increase, so volume will increase. As soon as temperature will increase, so density will decrease. But in case of water, what is happening? Up to 0 to 4 degrees Celsius, it behaves what? It behaves just opposite. So what actually happen in aquatic life, when climate due to climate change, what happens here? Due to change in a climate, what happens? Due to change in a climate, what happens? As soon as temperature start falling from 4 to 0, what will happen? Density will increase, right? So then 4 to 0, what will happen? Density is increasing. So if density is increasing, so what will happen? 4 degree water will be below. And as soon as see here, suppose there is a 1 degree, 2 degree, 3 degree and 4 degree. Okay, so if you see here clearly, see in the graph you can understand what I am talking about, right? Graph you can understand here. So see below the graph, suppose this is your 1 degree, 2 degree, 3 degree and 4 degree, right? 0, 1, 2, 3, 4. Okay, so let us consider 4. So this is your 4. So as soon as what happened, as soon as the outside temperature become 4, so what will happen? After that, as soon as the outside temperature reduces from 4 degrees Celsius to 3 degrees Celsius, so 3 degree has less density. So what will happen? Water with 3 degree will go up, water with 2 degree will go up, more up, water with 1 degree will go more above it, water with 0 degree will go more above it, and there will be a frost. there will be a ice formation. And what will happen, this ice will protect this water, so that its temperature will not further reduce. So temperature of the water inside this body will remain 4 degrees Celsius. And due to this 4 degrees Celsius temperature only, many aquatic lives are living properly. Otherwise, what will happen? There will be a chance of death, because there is extreme temperature reduction. But as soon as we have got layer of ice, so what happen? It protect as a heat insulator. It act as a heat insulator. So the temperature of the aquatic or underwater remain 4 degrees Celsius or 3 degrees Celsius. As soon as water atmospheric temperature become less than 0 degrees Celsius, suppose there is minus 20 degrees Celsius, in spite of outside temperature minus 20 degrees Celsius, your temperature inside the water lake and all will remain 4 degrees Celsius. And this is peculiar behavior of water, and that's why we call that anomalous expansion of water, because water water expand after 4 degrees Celsius, right? But water will reduce when temperature will increase. So when temperature is increasing, volume is decreasing. In spite of expansion, it is just contracting. So this is the anomalous expansion of water. Okay. So let us read what I have written here. Water exhibits at an anomalous behavior. It contracts on heating 0 to 4. So as you have seen here, 0 to 4 it contracts. 0 to 4 it contract, and the volume of the given amount of water decrease, and it is cooled from the room temperature until the temperature reaches to 4 degrees Celsius. So up to 4 degrees Celsius. After that, you increase the temperature, its volume will increase. This means that water has the maximum density at a 4 degrees Celsius. So from density diagram, it can be seen that maximum density is your 4 degrees Celsius, right? So maximum density is at a 4 degrees Celsius. I hope you have understood this, right? I hope you have understood this. Maximum density is your 4 degrees Celsius, right? Is it that? Okay. So this is your 4 degrees Celsius. Now, this property has an important environmental effect bodies water, such as water bodies and all. Okay, water bodies such. So in any lake, animal can exist. So this is the anomalous expansion of water. Got it? Now let us discuss about thermal expansion. This is the thermal stress and thermal expansion. So what happened in the thermal stress? So this topic we are going to cover is your thermal stress. So before going to the topic thermal stress, so we should understand what will happen. See here, as soon as you heat any object, what will happen? So this will try to expand, because whenever you will heat any object, so it will try to expand. Okay, but what is happening here? As soon as it is expanding, so what happens is side-wise temperature is constant, but here temperature is increasing. So this portion want to increase, and this portion does not increase. And due to what is happening here, what is happening? Stress has been developed, because it want to expand, but this body does not want to expand, but both are connected to each other. So what will happen? Stress will be developed. Same way here, you can understand here. Suppose this is your tensile force and this is your compression force. Okay, so you want to expand it, but your material want to contract it. So what will happen? It will create a stress. Okay, so whenever there is an obstacle, so it will create a stress in any material. Or you can also understand from a rod. Okay, rod. If you take a rod, okay, let us consider downside there is a rod like this. Okay, and you just make an obstacle. So what will happen if you heat this? If you heat this, then what will happen? It try to expand both the side, but due to obstacles, what is happening? Expansion is no there. So what will happen? Stress will be developed inside this. So how you will find that stress? So we will discuss that only. So now let us consider this rod. Let us consider this rod. So this rod is having initial length L naught and final length L. Okay, and change in length is equal to final length minus initial length. Can we write this? Now when we heat this, so what will happen? There will be a thermal stress production. Okay, so thermal stress, you know, thermal stress is equal to F by A. Thermal stress is equal to F by A. Now tell me, as per the earlier discussion, thermal expansion change in length is directly proportional to the original length into alpha into delta T. So can we write here change in length by original length is equal to alpha into delta T? So definitely we can write here. So can you tell me that strain, earlier classes I have already discussed about the properties of the matter, solid matter. So where I have taught each and everything, especially strain. Strain is equal to change in length by original length of any object. So here we can write here strain is equal to alpha into delta T. So is it okay now? Now tell me, as per the Hooke's law, Hooke's law, what it states? That has been taught in the properties of the matter, solid material. Okay, mechanical properties of, in the solid, right? So stress is directly proportional to strain. So stress is equal to gamma, that is equal to gamma is your Young modulus of elasticity. Young modulus of elasticity. Modulus of elasticity. If you are unaware of this thing, so please go to the previous video. Okay, of elasticity. Okay, so finally into strain. So can we write here strain is equal to alpha into delta T? So finally we have come to the conclusion that how much stress developed. Stress is equal to Young modulus of elasticity into thermal expansion, linear expansion coefficient and change in temperature. Okay, so note stress will only be developed if there is a restriction. See here, if you are hitting an object, okay, if you are hitting an object and it is free to move in both the sides, so no stress will be developed. Don't be confused here. Whenever there is a restriction in an expansion, then only stress will be developed. Okay, in spite of being heating, we don't get thermal stress. So here thermal stress is equal to 0 in this case. But as we restrict from both the sides, so what will happen? See here, as we restrict it with the both the sides, so what will happen? It try to expand, but due to the restriction, what will happen? Stress will be developed. So we are putting a heat from this side. Heat will be given. So what will happen? Stress will be developed. And if you want to find stress in this inside this, how much stress is there? So this is equal to force by area. So by the previous explanation, how we have come to the derivation, sigma is equal to sigma equal to y into alpha into delta T. So here we can write sigma is equal to alpha into y into delta T. Okay, so I hope you have understood now how to find stress development. But the thing is that stress will only be developed when there is a restriction in its expansion. So here if you are taking a rod which is free to move, free at one end. So if it is free at one end, so what will happen? Stress will be 0. But as soon as you will restrict, so there is a stress, and the stress if you want to find due to the thermal expansion, so you can find it by the formula. See here, if you want to expand this formula, so can we write here sigma is equal to alpha into y, Young modulus of elasticity is equal to T minus T naught, where T naught is your initial temperature and T is your final temperature. Okay, final temperature. So please go to that video. Those who are not understanding any Young modulus of elasticity, young modulus of elasticity strain. So please click below. There is a video where you can go through this topic so that you will able to understand this. Okay, so I hope I have able to complete the topic, and as well as I have made explanation about anomalous behavior of water. And next is your thermal stress. So how you need to find thermal stress. So use this formula to solve any type of numerical at all. Okay, so I hope this is sufficient for us. So I will meet in next video. Thank you everyone.